So I'm hoping I'm going to try to keep this easy for everyone, but there are a lot of contents in this session. Each of those topics can be really a one session for itself. So I'm going to do my best to fit everything in 1 hour. So I guess the best part is I don't have to finish on time because there's nobody after me. But I'm going to try my best. And I have some demos at the end. And if you have any questions, I will be more than happy to answer them at the end of the session. And thanks again for coming to my session. Well, I guess I can start. The best part of the presentation, which I am proud of, is those actually the blinks. I made them. It took a long time. Believe me, those blinks took some time. So what I'm going to actually try to, I guess, talk about is those exciting new features in SQL Server. Microsoft has been trying to keep up with all the other database engines, and adding all kinds of features in SQL Server. And unfortunately, right now, the database industry is kind of crazy. There's a new database engine comes up every year, and there's a lot of options out there. So Microsoft is trying to compete with them, and they're adding all kinds of new features in them. So I'm going to try to show you the most important ones they add from 2017, 2019, and 2022. And most of those are available in Azure SQL. If you are using Azure SQL, they should be out there already. So before I go in this session, let me actually talk about myself. My name is Hasan Savran, and I am owner of Savran Web Consulting. Mostly, I focus on Cosmos DB. And I have another full-time job. I work for a large industry company in the United States, and I'm located in Cleveland, Ohio. And this is my 4th year in Microsoft Data Platform MVP program. I'm very happy and honored to be part of it. I have my blog. You can check it out. I like to write about Cosmos DB, SQL Server, front-end, C#, whatever I know. I like to share out there, so you might find something interesting out there. And if you will have any questions later, you can just follow me on the LinkedIn or Twitter. I will be more than happy to answer any of your questions from there, too. So let's actually start with history of JSON in SQL Server. JSON, well, developers were actually saving JSON even before the 2016 when it got introduced to SQL Server. At the end, it's string, so you can just save it as string. But I guess Microsoft see that as an opportunity, and they said that, OK, they're already saving the JSON in SQL Server, so let's actually not create a new data type for JSON. So they just kept it as varchar, well, and varchar max. When they introduced it, that's the data type that actually Microsoft suggested, and I believe they still suggest to use this one. If you have some special characters, you can use the varchar max. If you don't have any, you can use varchar max. Both of them are going to work. In that 2016, when they introduced, they actually had 4 functions. Those are the isJSON, JSON value, JSON query, and JSON modify, which I will cover them in a little bit. But when this actually came up first time, well, as you might guess, our DBAs had some issues with it. And they had some concerns, and their concern was valid. First of all, varchar max or nvar varchar max, well, they cannot be indexed. So that was the first concern. Second one, the data is getting saved in SQL Server by 8 kilobyte pages. Well, since we don't define any kind of number here, and it's max, it's not really easy to optimize this varchar max in SQL Server. And also, updates takes much longer because of the data type. So those were the DBA's concerns, and they are still the concerns. So from there, well, in 2017 came up with some actually good additions. So in SQL Server, you have the memory optimized tables. In 2017, actually, Microsoft added the JSON functions in memory optimized tables. That kind of opened a lot of new kind of adventures for developers because basically, Microsoft lets you actually use your own Redis environment in SQL Server by making it available in the memory tables. From there, in 2019, there were no updates. And 2022 just came up last year, and we actually see some new functions, and some of the functions got upgraded. Most of the functions you see in 2022 is really about creating arrays, creating JSONs in SQL Server. Before 2022, you had to do everything in the, if you are using C# or MVC in .NET, then save it to SQL Server. In 2022, you can actually change and create new JSON documents in SQL Server. Before we go into, I guess, the details, what those functions do and how they work, first we kind of need to learn kind of like a language that you kind of need to query those JSON documents in SQL Server. So Microsoft calls those JSON path expressions. As you can see, it just starts with the $sign here. And $sign represents the context of the JSON. So if you are looking at a JSON document in a column, the whole document is the $sign. From there, you are going to use the dot operator, and that's going to indicate the members. So you can actually go and query the JSON schema by that. You are going to use the key names. For example, we have here post ID is the first member. So if you're going to say $.post ID, that's the value you want to get from the JSON document. If you have any kind of special characters in the key names, it's totally valid to kind of start with the double quote. As you can see, we have a white space in the middle. So it works the same way. You can have the array elements. And there are two types of path modes in the JSON documents in SQL Server. One is the lex, which is the default mode. The other one is the strict. So you don't really need to define it. But as I say before, the lex is the default one. So what actually happens here, for example, the last one here you see order is. Well, order is does not exist here. So in the lex mode, if you're going to try to get order is, SQL Server is going to return null. If you are actually using the strict, SQL Server is going to actually throw an error and tell you that this doesn't exist. So you can have some kind of control on the schema. Even it's schemaless, but you can have some kind of control in the schema by using the strict option. So by knowing that, now we are actually ready to kind of look at those functions in SQL Server for JSON. JSON query function is the first function, which actually queries the JSON document, and it actually returns you a JSON document from that. The default value for the optional path is the $sign dot, which means that you are getting the whole content. So you are not passing any kind of, I guess, the path. If you use the path, then it's going to return an array, or it's going to return an object. So those are the two things it can return. And the return data type is nvarchar max. So if your JSON is not that big, you can always cast and convert that to make things a little bit faster if you need to. So let's see actually this in action. So in the left side, you see our document. It's a sample JSON document. And we are going to try to run JSON query. As you can see, I'm just passing the return delivery data. That's the name of my column. And this is the path that I want to get. So events 0, which I should get the first one here. And I'm just calling it as event. So when I run that, you're going to see that actually it returns the JSON document. It returns that object here for me. So let's see another example. Now, I am looking at the events 0.event. And what do you think this is going to actually return? Any ideas? It is not going to return anything because, as I said before, yes, it exists here, but this is a value. This is not an object, or this is not an array. So JSON query is not going to return anything for that. So you kind of need to be careful when you use JSON query. 3 things you need to know. It returns object or array, and it returns nvarchar max, and it returns it as JSON document. It doesn't return as a scalar value. Now, let's look at the strict. We actually talked about the strict here before. And let's say we are looking strict.event. So now I know that this is actually returning event because by default, this is a lex. So it doesn't care if it's there or not. But in this case, it's there. But at least we are going to be able to see the error here because we are doing the strict here. As you can see, it says object or array cannot be found. So if we want to get the value, then we need to use the JSON value function. And JSON value function is very close to the JSON object. but it returns a scalar value. It does not return a JSON document anymore. And the data type is varchar 4000. If the data you are trying to pull is larger than varchar 4000, you should use the OpenJSON function rather than JSON value. I never had this issue in my experience. All the values were less than 4,000, so I'm not going to be able to talk about OpenJSON here, but if that's the case, that the value is larger than 4,000, you might need to use that. So now, with the JSON object, we could not retrieve the event here. With this one, we should be able to do that. So in here, as you can see, I am using the JSON value. Return delivery data is the name of the column, and I have the path, which is the events 0 event. And that actually gets the string of the scalar value for the event object. Next one, as you can see, I am looking for driver ID. And driver ID is actually in the second array, not the first one. So this one is going to return null because it's lax mode by default. But if I'm going to actually use a strict for the same one, well, then I'm going to actually see an error. SQL Server is going to throw the error because I'm using the strict, and it needs to exist for it to get returned. Next one, probably the most popular one, is JSON document. As you might guess, it just returns true or false. Since there's no JSON data type in SQL Server, in some cases you might want to check in your where clause before you pull the data if this is a JSON or not. So in 2022, we actually have some optional JSON type parameter is introduced in the 2022. If you have 2016, 17, 19, you don't have that option. So in here, rather than checking if JSON is a valid JSON document, you can actually check if it's a value, if it's an array, object, or scalar, if you like to. So for example, let's see an example. In here, I'm just looking at, actually, this is my data again. In the left side, you see, I'm just checking if this is a JSON document, valid JSON document, and it returns 1. If you want to make it more complex, we can put this JSON query in JSON. In this case, I am actually asking if events is an array. And it's in my var filter. Since it returns true, and it returns the data. So this is great. You might need to actually put the isJSON in your var clause just to be safe. But there's another way to actually deal with this problem. And that is adding a constraint on your table. So every time you insert, every time you update your data, SQL Server will actually run this isJSON for the entered data, and it will accept it, or it won't, depending if it's a valid JSON or not. So that's a good kind of, tip. Next one is JSON modify. JSON modify just modifies the JSON document, and there are 3 items here that you need to know. Append is only for arrays. So if you have array 1, 2, 3, and if you want to add 4 to the array, you might need to use the append. So the 4 will not replace the 1, 2, 3 out there. And we have the lax mode. And lax mode, whenever you are updating, SQL Server does not care if it's there or not. In the strict mode, whatever you are trying to update out there, it needs to be there. If not, the SQL Server will actually return an error. And also in the lax mode, if the new value is null, then your property will disappear from the JSON document, since it's not suggested to kind of keep the nulls in the JSON document because it keeps them large. So as you can see, I have one example here. I am trying to update my return delivery data. That's my JSON document. And I am saying update the driver ID to 18 here. Next one is JSON array. That's one of the new ones, came out with the 2022. And this one just constructs a new JSON array in SQL Server itself. And there's an optional parameter here, which is a null clause, which kind of controls if you want to keep the nulls or not in the JSON array. So in here, if I don't pass anything, it just returns empty array. And as you can see, I can create arrays by just passing strings here. So both of them actually returning the same one. As you can see, I am using the absent on null, which I mean that I'm taking the null out from here. So they are the same thing. If I want to actually save the null, then I can use null on null. I know there's a lot of nulls out there, but as you can see, this returns the null in my colors array. So you have some control with the nulls with this way. Next one is constructing the JSON document in SQL Server. And this one actually has the same parameter. This kind of controls if you want to keep the nulls or not in the JSON document you create. And this returns nvarchar max. Again, if hopefully your JSON document is not that large, if it's 2,000, 3,000, you can always convert that to whatever you have in your database. So in here, for example, we are creating a JSON document. Name is Hasan, age is 18. As you can see, it just returns the JSON document here. And my address is null here. Since absent or null, address getting disappeared. So that is kind of important. You kind of need to know that parameter and use it well if you don't want to have like any surprises. And in here, on top of that, you can actually create arrays in the JSON document. So as you can see, it's the same object. I have my address null, and I'm creating kids array, and I'm passing the names here. And I am using null on null. So as you can see, my address is here now. And you can use those parameters. They work the same way in the JSON array or JSON object. Another one, JSON path exists. So in some cases, you might need to filter or check if the property exists before you make any decisions on your application. So you can use the JSON path exists for that one. So again, I'm just using the same column name, and I'm just passing the filter here. And I'm just checking if the driver ID does exist in the 0, which is not here. So it returns false, it returns 0. Next one, well, my driver ID is here, so I say, well, let's try if it's in the second one. And as you can see, it returns 1 here because driver ID exists in the JSON document. Now, this is another interesting thing that you might be able to use in your application. So you can actually return data as JSON. So you know their SQL Server can return as XML. So by just using the for JSON at the end, you can actually return whatever you are returning in JSON document. And there are a couple of parameters you can use. If you don't use anything, it's going to be auto. So all the select the column names is going to be your property names. And that's going to be the schema of the JSON. If you want to actually use the, maybe change the names or add like nested objects, you can do that with the path. So for example, you might have a large document and you might maybe create a nested object, let's say customer, in the object. All you have to do is just change the aliases. For example, let's say customer.age, customer.name, customer.address. That will actually create a nested object in the document for you. And you have to use the path for that one. If you like, you can change the root option. You can change the root name by the root option. By default, there's no root name. And other two popular ones is include null values. If the null values are not there, and if you want to see them, you can just use the include null values, so it will be in the return object. By default, null values will not be there. And without array wrapper, so whenever you actually use this, all objects comes up as an array. So if you are looking for only one customer, you know there's going to be one document. So you can just use this one at the end of it. So the data will come up as a one JSON document rather than arrays. Now, what you can do with this? You can do really kind of interesting things with that. Because if you really think about the, let's say talk about the front end. You have a form. Usually your objects, the class names matching with the form HTML names. MVC knows how to map that. So you can actually, you don't need to worry about all that mapping. Because form is actually returning as a JSON document. So potentially, you can do the same thing coming from the JSON document. So you might not even need an ORM, which is actually doing that for you. As long as the names are matching and it comes as a JSON document, well, the .NET should be able to handle that. So to do that, this is mostly the kind of default and easy way to get the data from SQL Server. This is not going to work. The main reason this is not going to work is, well, when SQL Server actually returns the XML or JSON, it actually splits that in 2 kilobyte chunks data. So because of that, if the data is larger than 2 kilobyte, then you might not get the all JSON document if you are going to go this way. So the best way, there are two ways to actually fix that. This applies to JSON or XML. So what you can do here is you can actually create a new result here, and you can say that this is mvarchar max, and let SQL Server to worry about put all of those chunks together in SQL Server. So when it comes to you, actually this will work for this one now because it's going to come up as a one document. That's one way. Another way is you can use the reader.read. So as long as there is something coming up from SQL Server, all you are going to do is you can actually append that to current document. So both will work, whichever is easier for you. You can actually get the JSON document like that, and from there you can just convert your objects very easily. Well, JSON document, well, we are still in SQL Server, so we kind of need to worry about indexing. Any of those functions, if you are going to actually run it, I would say 90 to 95%, maybe 100%, they're going to go table scan. So when go to table scan, well, your DBS are not going to be happy, and you kind of need to fix the problem, because if you are going to have a lot of users trying to hit those store procedures or functions, then you might be in issue. You might be in a problem. So to fix that problem, SQL Server actually team came up with a different way to actually fix that. So we have computed columns in SQL Server. So those are really like the prepared, almost like frozen meals. They are ready to out there to kind of consume. So and usually you are calculating things in the same row and just putting it out there, so you don't have to do it every time when you are selecting the data. So we can use that with the JSON value function and actually create a new column. So you don't have to actually use the JSON value every time you try to run this function. So in here, for example, I have this one here, and I'm looking for driver ID 17. Give me all the documents that driver ID 17 is in the document. Depending how many JSON documents you have, that might be a pretty heavy query. So to fix that problem, what we actually do is first, we go and create a computed column for this. And on top of that, as you can see, I am converting the data too. So in here is a string, but I made it actually integer here. And I make it persisted. Persisted means that you are actually physically copying this data to the table itself, so it doesn't have to calculate every time you query. So that data becomes like physical on that table. From here, I can create an index on it because that's a column now. And I can create a column on the virtual ID, virtual driver ID here, as you can see. And from here, I can rewrite my query. As you can see, I don't need to worry about JSON value function here. Virtual driver ID is 17, and I'm using an integer here. So this can really help you a lot to make things really fast in SQL Server. And if you really think about it, this is a great addition because you already have the relational data out there, and you have this, well, node schema data. You're in the same environment, and you can join them together. And that can be really powerful, depending on what we are doing. So that was the JSON part of the talk. The next one is the graph database tables. Graph database tables are not new. And SQL Server actually started to support them in version 2017. So before I go in technical and try to explain what it is, let's try to explain actually why we might need it. So we live in the connected world. And when things changes in the world, well, usually they trigger other changes. And that usually trigger business changes. Your business might see a new opportunities, and you might be selling X. Now you are going to start to sell Y. Well, when that happens, what happens? Your data changes. Well, when your data changes, then you are in trouble because you have to kind of go back and create a new schema for it. Or if you are lucky, you can maybe use the current schema and add new tables or new relations to actually handle that. That would be the best if you can actually do that. So that really is a problem for some businesses. For example, I'm not sure if Blockbuster was in England or not, but it was one of the largest companies to rent videos. That was entertainment in older days. There was no Netflix. So Netflix came from nowhere, and believe it or not, Netflix used to actually send the DVDs by mail. So they didn't really come up as a digital or streaming company. And it was great because, well, they were sending you the DVD, you watch it, and you send it whenever you like to send it. So they were not charging you any kind of late fees. So that's the way that actually they started. Then actually they go, we started YouTube, then Netflix started to have their own service. And Blockbuster, unfortunately, it was a large company. It was like $5 billion company in those days. And they didn't really I guess, maybe give them a chance. They refused to actually buy Netflix. They had a chance to buy them. They didn't buy them. So wrong decisions, and maybe they didn't have the infrastructure, because if you really think about it, you are talking like DVDs, everything is physical. How are you going to actually take that and put in the digital and create this system from scratch? That might be one of the challenges they had. At the end, the data changed. They didn't respect that, and now they are not here. Auto industry is another one. So lately, you see all the information about the cars are driving themselves. There's a different way to actually sell the cars now, especially in United States. There's like vending machines for cars, so you can actually go and buy them by token. So there's like totally different kind of things are going on in the auto industry. And I am from the insurance business, so that's a challenge for insurance business, because you might have a customer come to you for an accident, and they say that, yeah, you know what, I had an accident, but I wasn't driving the car. The car was driving itself. How do you write a policy for that, and how do you actually, I guess, handle the claims for that? So that's totally, I guess, challenges coming up with the auto industry to many businesses. Police or emergency, that's another one. I don't know if you heard, but there was a person who was sleeping in the car was driving itself. The cop was trying to stop him. Well, it didn't stop. So now if you are the engineer of one of those cars, you might, rather than looking front, maybe you want to look at back too. So if something is trying to stop you, maybe you will stop the car. So data changes, business changes, and you kind of need to respect that. And I guess handle that with some kind of schema. So the problem is that. So what happens is when the business evolves, when the business changes, your data needs to be flexible. Whenever you're actually creating a data model today, you almost need to think about the feature, what might change. So it will be easier to create new domains and new relations in your tables. So what are the options? Options are, the first one is the relational, which is really not that good option when it comes to changes, because you have a schema, and it's not easy to change. If you have 10, 20, 30 tables, it's never fun to kind of add more tables onto that, or try to change the relations. You might have a primary key, foreign key. It's a nightmare, I'm not going to lie. Rather than that, we have key value, which I guess Redis can be an option for that. White column databases, Cassandra is an option for that. And the graph tables are the option that I'm going to cover here. So in SQL Server, as I said before, you need at least 2017 or the Azure SQL to be able to create the graph database tables. The best part is you don't need to learn a new language. You are still going to use the T-SQL. You don't need to buy different servers and try to find people to maintain them. You have the SQL Server. You know it's the same SQL Server. And you can join to other tables. So if you have current data models, they are not graph database tables, you can actually join them to graph database tables. And that will be very powerful if you can actually create a flexible model with the graph database tables and join to your current tables. And it's fully integrated in the SQL Server engine. So even SSIS and SSRS, if you have any, it will still work with the graph database tables, since it's the SQL Server itself. So if we go a little bit more technical then, I guess, try to explain them what they are, is, well, in graph database tables, we have two types of tables. The first one is the node tables, and that is mostly for the entities. Other table type is the edge tables, which actually keeps all the relations. So the relation really becomes the first-class citizen by edge tables. In node tables, we have a special column named node ID, and that is really the primary key for each entity. And that is auto-populated. You don't have to kind of change anything on it. SQL Server just uses that to find the data, so you will never need to update it, delete it, or anything with it. But if you write the select all from that table, you will see the node ID. And, well, I think that there is a JSON document in it if you actually look at it with the select all. And just like any other tables, it can have any type of data type. If SQL Server supports it, you can put it in the node tables. Edge tables, where the actual magic happens. So just like the node table, we have edge ID. And edge ID is the primary key for each relation. And just like the node ID is a JSON document in it. And you will have no business with it. It will get auto-populated. At least there, just FYI. It can have any type of columns. That is very interesting. If you really think about it, we used to put all the columns in one table, and your columns can get really large. Your table can get really large because of that. In here, you can actually put the metadata about the relation in the relation table, so they don't have to go and stuck in one table. We have from ID and to ID, and those are the special columns you need to actually create a relation. So if I give an example for that, let's say we have users table. Users table is an entity table. And we have edge table. Let's say one user likes other user. So we create an edge table named like. So we want to create a relation. Let's say we have a user named Alec and Anna. We want to say Alec likes Anna. To do that, we are going to get the node ID of Alec and put in the from ID. And we are going to get Anna's node ID, put in the to ID. So that's going to create a one row in the edge table, and that's going to create a relation between two users. As you might guess, there's a lot of, you can create dynamically. It doesn't have to be users. It can be other tables. So the relation becomes really flexible by doing this. Relations cannot be updated. So if you really think about it, you like somebody or you don't like somebody. So you cannot go and actually change the from ID and to ID. If you have other columns, you can go change them. But all you can do here is insert or drop. You cannot update from ID or to ID. Directions are important. So as I said before, Alec likes Anna. It doesn't mean that Anna likes Alec back. So the direction is going to be important. The way that you are inserting the data and you are querying the data is important for graph database tables. As I said before, you still need to use the T-SQL. One of the main, the function you need to learn is the match function. Match function actually goes in your where clause, and that's how you are actually searching the graph database tables. Minimum, you are going to need two entities and one relation. One entity needs to go to our entity by using a one relation table. And you are going to use the arrow character to figure out which direction we are going. And we are going to use the parentheses to remark which table is a relation table, because it can get confusing sometimes. You might have 5 tables, 10 tables, and you might want to guess which table is a relational table. So that kind of helps with you that. So here's an example. We are still using the select statement and from. As you can see, we have products, users table. As you might guess, those are my entity tables, and wished is my relation table. So my match is actually going from users table to products table by using the wished relation. And I'm looking only for user ID 1. So this is going to return me user ID 1's wish list, as you might guess. In 2017, we actually had some new features included in the, actually it's 2019. 2017 is introduced, and constraint actually introduced on 2019. So if you look at this one, for example, we have a product and user table. As you might guess, my relations should be going from users to products. So my product should not buy a user, or product shouldn't like a user. So to control that, you can actually use the edge constraints. As you can see, you can add one. What I'm saying here is I want to add a constraint, and my connection for wished should be going from users to product. If you want to have multiple for the same one, you can actually couple of them add here. And also, you can actually control what is going to happen if somebody is going to go and delete one of those users or product. So in this case, for example, if that happens, and let's say my user 1 is disappeared, somebody deleted, all the relations will be deleted automatically in SQL Server if you do on-delete cascade. Or if you don't want anyone to delete anything, then you can say on delete, no action, and that means that they cannot actually delete anything if there's a relation between two entities. So that's pretty useful. Graph database tables still in SQL Server, so we still need to worry about indexes. And from ID and to ID, you are never going to use them in your where clause, but when you actually you are kind of using them by using the match function. SQL Server actually handles it. So it's important that you actually create indexes on them. So in here, for example, I am looking just like the Amazon. When you go scroll down, Amazon shows you, you are looking this product, but I have some other products like this. So you can do that easily at the graph database tables. So as you can see, I'm going from my product table to product table by using a like product relation. So that is going to return all the alike products like product ID 1. So thanks to my indexes, actually you see an index seek here. Without those indexes, you are going to see a table scan, and well, things can get really slow if you don't have indexes on those from ID and to ID in the relation tables. So this was the graph database tables, and the third one I'm going to cover here is the memory optimized tables. There are two types of tables that you can actually create in memory in SQL Server. And the first one is durable tables. The data first goes to the memory, then it goes to your disk. So if a disaster happens, you still have the data, and it will come back from disk to memory when the SQL Server comes back. The second option is the non-durable tables, which I have most of the experience with. In here, the data only exists in memory. It never hits the I/O, or it never hits the disk. So as you might guess, this is really fast. And this is great if you want to cache the data. This is great for session state, for ETL data staging. If you are doing in the SSIS packages and if you have a lot of data, you can actually do that by using the non-durable tables. So you can really kind of compare that with the Redis in this moment, really. So indexes, there are three types of indexes you can actually create in memory tables. The first one is the hash index. So this is just like the Redis. If you have the key, you get the value. So you can actually create a hash index on that, and it will make that pretty fast. If you are looking, which you cannot do in Redis, if you are actually querying the data in memory, you can use the non-cluster indexes, and those are great for if you have kind of inequality, order by, or any kind of range fillers, you can do that. And column store indexes are available only in the durable tables, and they kind of make things, if you are analyzing the data, it will make things much faster. Next one is the natively compiled store procedures. So as you can guess, our data is in the memory already, so it's pretty easy to access the data. But we still have to kind of worry about how to get the data with the optimization going on in the middle. You can actually create a natively compiled store procedures. So when you actually create the store procedure, it compiles it first time, and it does all the optimization. Then actually it creates a small application and puts in the memory. So now you have the data in the memory. You have the application which actually gets the data in the memory. So it cannot get faster than that, I guess. So this is great if you are, in performance critical applications. You need a lot of things going on in the application. You can actually use that. If you are doing aggregation, that is great for that. And if you need a lot of, I guess, many users hitting the same time, that's great for that too. So that's going to bring us to JSON. So we've covered JSON in the first part. Now actually you can actually create the JSON in the memory tables, especially in the non-durable tables. So you can actually cache, and you can create a redis-like environment for free in SQL Server. So on top of that, you can actually create the computed columns, and you can actually query the JSON documents that you have. So for that, let's say we have, usually that's what we have in Redis, we have key and value. You have to know the key to get the value. But in SQL Server, you can use the JSON value function and create computed columns. And let's say this is our object. So I can easily create different columns, and that's going to be actually staying in my memory. And I can query all this stuff that I cached in the memory easily by using this. Now, this was the presentation, so I can actually jump in and show you some demos. So the first demo I'm going to show you is going to be for graph database tables, and I'm going to actually try to show you that graph database tables actually handles all the other data types that we have in SQL Server. So let's actually see what we are doing here. So the problem we are trying to fix here is, let's say we are a company like Amazon. We have a lot of products, we have many warehouses, we have a lot of users buying stuff, and let's say we are sending, shipping is free. So it's pretty important that we are actually sending these products from the closest warehouse to the user, so it will actually cost us the less amount of money. So that's what we are trying to fix here. So to fix that problem, first we need a table for our products. As you can see, all I have to do to make the graph database tables, all I'm doing is I'm still using the create table syntax by just saying as node. That makes the table a graph table. So it's really that easy to create a graph database table. And so I have a product table, which is going to have all my products. and I have warehouses. Those are my warehouses. So what you actually see here, I have a geography data type. That is the geospatial data type SQL Server has. And since I know my warehouses, I can easily find my latitude and longitude and put it right there. So I can make the decisions on that. Next one is my users. I'm going to list all my users here. As you can see, again, I have the geography here. I don't really know exactly where my user is. As long as I know where the city is, I can get some kind of estimate for it. So that's the city geography. That's why I have it. From here, I have some, well, I need to create some relations. Now, warehouses are going to have products. And that means I have that in-stock relation table. And all I'm going to actually do here is just create the table and put some index on it. Then I am going to need, users are going to buy products. As soon as they pay the money, I'm going to actually create a row in here. That's going to be in process. It's going to be between the users and products. And as you can see, I'm actually adding a new column here, sold on. That is the time that the actual transaction happened. So from here, I'm just going to use insert statement. Nothing is different here, especially for the node tables. I'm just putting some products in it, some users in it in my users table. As you can see, that's how you declare geography here. So this is latitude and longitude. And from here, this is my warehouses. And I'm creating a couple of in-stocks. So those are the products I have in warehouses. Those are the relations. So I guess let's look at this one here. So it's the insert statement, as you can see. This is my node ID from the warehouse. And this is my node ID from product. So that's the from ID and to ID. That's how the relation is getting created there. So let's continue here. It's going to create a bunch of in-stock. So those are my products in warehouses. And the next one is the in process. So these are the products I sold by those users. And I'm putting the get date out there because that's the date that is sold on. I had that column there. So I'm just going to put all this data. That's the first part of this demo. Let's see. And let's run it. Now I have my data in my tables. The next, I'm going to actually go and look at the data. So I had two queries here. I'm going to run the inner query first, and so you can actually see what I have here. What I'm doing here is st_distance is a geospatial function of SQL Server. And all it does is it finds where the city is and find the distance between city and the warehouse location. And I'm just dividing this number. That gives me miles. By default, it gives you meters. So that's the first function I'm using. And I am using some window functions here. And my match is going from users table to the products table by finding what is sold. In the same time, as you can see, my direction is going this way. And I can still continue there. Other direction is actually going from the warehouse to the products table by using the in-stock. So that's actually find all the sold products that I have in warehouses with all the distance that with the st_distance function. So if I run this one, you are going to see we have a user named George. He lives in Virginia Beach. And he bought 27-inch monitor. And those are the warehouses I have, those 27-inch monitors. And by sorting by the miles, which comes up from the st_distance here, I can tell that the closest one is in Minnesota. So if I actually send this from Minnesota, that will be the cheapest way for me to actually send it. So all I need to do here is, since I'm using the window function, I am actually sorting by the priority at the miles here. All I have to do is go and get the number one for each. So that's going to give me all the items that I sold and where I should actually send them from. As you can see, those items should go from these warehouses. As you can see, I didn't use any AI. I didn't use any kind of smarting. All I use is graph database tables and available data types of SQL Server. And I'm able to kind of make smart decisions with my business by doing this. So that was the first demo. The second one is large data. So what actually happens usually when I show that to DBAs, they say that, oh, Hasan, you're cute. You have only 10 rows out there. What happens here if you have 1 million, 2 million, 3 million? I was like, well, that's a good question. Let's see what's going to happen. So I'm not going to run the whole script here because it takes a long time. But what I did here is I get the Stack Overflow's database and put in here. I create my own kind of graph database schema for it. So let's see how many actually rows we have. So those are while statements I kind of write. So let's see, those are the items I created by looking the Stack Overflow. And as you can see, now I have almost 1.1 million questions. I have 2.6 million answers. And all of the questions are answered by the answered queue. And I have a good amount of, the good amount of questions here. So now if I try to, query my data, let's see what's going to happen. So the first one here is actually going from my users table, going to the questions table, and by looking the ask relation. So that's going to find all the question asked by user ID 1. And we have a good amount of data here. If I run it, still 0 seconds. So it was almost the same one with the 5 or 10 rows. And this is my personal computer too, so it's not a server. So far, so good. If you want, we can actually make this even, more complex. So we are looking all the answers here. This one find all the questions asked by the user. And I'm continue out there, and I'm just saying also give me all the answers for question ID 11 for this user that I'm looking for. So this is more kind of complex. And if I run that, still 0 seconds. So that is a demo for the large, database. And the next one, which I did not cover, is another function of SQL Server, which is the shortest path. So now I think you understand, we have the graph tables, we have entities, and there's relations between each entities. And we call those hubs. So if you want to kind of know what is the relation between two entities, you can actually use the shortest path, and it will give you the shortest way to actually reach to that data from this data to the other data. So that's mostly good for the data science. And if you have like any kind of fraud or anything like that, this can kind of give you all the relations easily. So it's not that easy to demo this one. So the best I came up with is, let's say we have people. That's my node table. And I have a relation table friend. So we know this person is friend with this person. So that's what I am creating here first. So let's actually create that. So I have a bunch of people, and a bunch of people knows each other. That's what I'm creating here. So let's have the data first. Then I am going to use this shortest path function. This came up with the 2019, by the way. So I'm going to run first the inner query. So what I'm trying to do here is we have a user named George. George likes to meet Lisa, but we don't know how. What is the shortest path for George to actually go and meet Lisa? So there are many people in the between. So if I am going to run this one here, as you can see, this is all the data we have for George. So George knows Bob, and Bob knows Katie. So as you can see, this is the last node I have. So Lisa is here. So the shortest path for George to meet Lisa, he has to go to Bob. Bob needs to introduce him to Katie. Katie needs to introduce him to Mike, and Mike needs to introduce him to Lisa. So that actually finds the shortest path between the entities. So if I actually run this one, it's just going to show you the shortest path. It's going to just take everything out from there. Now, data changes, right? That was the whole kind of my, selling point to you. Data changes. Well, shortest path is great with that. So if I'm going to actually introduce more people here and run this again, let's run the whole thing so you can see the difference. Well, now I have another person here. I think I write the text here. So I introduce Bob to Ted, and Ted knows Lisa. So now my shortest path actually knows that rather than going this way, well, if he goes to Bob and Bob knows Ted, then he can introduce to Lisa from that way. So that's the shortest path. Unfortunately, it's not that easy to kind of understand what's going on here because you can see there is all kind of attributes here we have to use. This is really like a group by almost in the graph database environment. And we are still using the match here. So let's see, the next one I am going to share with you is indexing. So I talk about the JSON, and indexing is important for it. So there are two types of indexes you can do in the JSON. So in here, for example, I'm creating a very simple redis-like almost schema. I have an ID, and usually you have a summary. So in here, I'm just putting, I need to know the ID to get what the summary is. Summary is the JSON. And let's say we have a lot of data. So I'm going to insert 8 million documents in 2 tables. One of them is going to have a regular index, non-clustered index. The other one is going to have column store index, which is going to actually compress the data. And it's going to be much better to actually analyze your JSON documents with the CCI, column store index. Now, I'm not going to run that because that runs a long time. So that's what I'm doing here. I'm just inserting the 8 million documents here. So all I'm going to show you here is how much space they actually take. The first one has non-clustered index on it. And I have almost 8 million rows in it, 8 million JSON documents. And really it takes, I think, 5.7 gig of data. If I'm going to put the CCI on it, which is the column store index, it might look similar, but this is half gig. It's not 5 gig anymore. You are actually saving 10 times compress on this. So you are saving a lot of storage. And if you are doing any kind of analyzing, like finding the minimum, maximum, other stuff, CCI will help you a lot because now it doesn't have to go and find, read the 5 gig of data. It can actually do it much faster because I/O is going to be much, less pressure on the SQL Server. And we talk about the Redis. If you want to create a Redis-like environment in SQL Server, it's pretty easy by using the native store procedures. So in here, as you can see, I am creating a memory table here. And I have the key. This is my value. And I have some other items here I can use to actually clear my cache if I want to, or expire the cache. So the first thing I need is a store procedure to load the data. So as you can see, I am just creating it here. All I'm passing my key, just like Redis, and this returns the data, whatever I'm looking for. So in here, as I said before, this is going to actually go in the memory too. So this is going to actually compile the application and put it in the memory. So your data is going to be in memory, application is in the memory, and it's going to be much easier to get the data and much faster to get the data in this way. So that's loading the data. To insert the data, I'm just creating another store procedure, as you can see. I'm just passing the key and value. This is still in the memory, so everything is fast. And I need something to actually, expiration, and Redis has that. So to do that, I am just creating a trigger here, cache expiration, and this is going to get triggered every time I insert and update something. So this is going to actually clear the cache. So you are really creating almost like a Redis-like in SQL Server. The best part is you can actually query the data in SQL Server with the JSON value, JSON query functions. But I believe that was the last demo I have for you. And I hope everybody learned something new. If you have any questions, I'll be more than happy to answer them. Let me actually put my connections here so you can see it. But thank you for coming to my session. Yeah.
It's a related question regarding graph tables and using EF4. Do you have a good way to use EF4 and graph tables?
Unfortunately, no. I don't know any ORMs right now using them. Mostly because of when you are inserting the relations table. Because you have to actually query 2 tables to insert 1 row. So I think that's where the problem is. But I don't know any ORM right now can handle that in SQL Server. Yeah. Yeah, you might need to create a store procedure for that and run that one, but without that, no.
Hide it behind the view or something like that. But
Yeah.
you need to redefine the query. So.
Or you can use the for JSON, the one that I show you. Actually, if you get rid of the ORM and use the for JSON, the data comes as a JSON, it can just automatically, I guess, map it for you. All right, thank you very much.